Good day, everybody. This is Professor Benavides. Let's finish chapter 8 on functions. Now, we're going to be drilling down on three things: functions in modules, styling functions, as well as summarizing the entire chapter. So it was quite a chapter, but a very important chapter. This chapter is indispensable for the chapters that will follow, such as Introduction to Object-Oriented Programming. So we really need to get this stuff down. Let's take a quick look at the cheat sheet that Eric provides us. You know I'm completely sold on these. And so this is his summary of everything that he talked about in the chapter. He talked about what functions are, how to define them, how to pass information to them, positional keyword arguments, default values, return values, passing a list to a function, passing an arbitrary number of arguments, a lot of topics. It's probably one of the best chapters on functions that I have seen in the book. He also talked about structuring functions. I think that's the nature of the topic for today. And of course, modules, which is the topic for this video that I'm making right now. So let's go ahead and get right into it. So storing functions in modules, introduction. What are some advantages of using functions? Well, one advantage of functions is the way they separate blocks of code from your main program. By using descriptive names for your functions, your main program will be much easier to follow. You can go a step further by storing your functions in a separate file called a module, and then importing that module into your main program. An import statement tells Python to make the code in a module available in the currently running program file. So why store your functions in a separate file? Storing your functions in a separate file allows you to hide the details of your program's code and focus on its higher level logic. It also allows you to reuse functions in many different programs. When you store your functions in separate files, you can share those files with other programmers without having to share your entire program. Knowing how to import functions also allows you to use libraries of functions that other programmers have written. So our first stop on this journey is to talk about importing an entire module. How do we import functions? Okay, so to start importing functions, we first need to create a module. A module is a file ending in .py that contains the code you want to import into your functions program. So right here we see a file called pizza.py. It only has one function in it, but it could have many functions. And notice how it doesn't have any function calls. It's simply the function definition and the body. Okay, so if you were to run this, you're not going to get anything because there's no call to it, right? So what we're going to do is we're going to create another file, and in this other file we're going to import the first file, and then we're going to use the dot operator to go ahead and access that function. Okay, so here at the very top we see our import statement, import pizza. That imports the pizza module, so that on line 5 and 6 I simply have to say pizza.makePizza. I pass it a size of 16 and pepperoni. I can call it again, size 12, and I pass it mushrooms, green peppers, and green cheese. What happens here is that I am then using the make pizza function, and it receives size and it receives asterisk toppings. That creates the tuple, which allows us to then navigate or iterate through the toppings and print them out one at a time. So let's go ahead and run this. And you'll notice that we get the output very similarly to if we had this all on one file. Certainly you don't see much benefit in separating it right now, but later on you will see that this can be very helpful when using, for example, libraries of functions, or if your program has gotten very large and you're needing to partition it to organize your program. So how does Python handle the import statement? When Python reads the file, the line import pizza tells Python to open the file pizza.py and copy all the functions from it into this program. You don't actually see code being copied between files because Python copies the code behind the scenes just before the program runs. All you need to know is that any function defined in pizza.py will now be available in makingpizzas.py. So making pizzas or making underscore pizzas 1.py. I called it 1 because I have a variety of examples that I'm going to be showing you and building on this as we move along. So how do we call a function from an imported module? To call a function from an imported module, we enter the name of the module you imported, pizza for that matter, followed by the name of the function, make pizza, separated by a dot. It's referred to as dot notation. So pizza dot make pizza. This dot operator here is really, really, really important. And this is like the beginning of object-oriented programming. We're going to be talking much more about that in the next few chapters. Using the dot operator is going to be used quite a lot. So what is the syntax for calling a function from an imported module? Let's go over this. Let's reiterate this again. The first approach to importing, because we're going to go through a long laundry list of different ways of doing this, in which you simply write import followed by the name of the module, makes every function from the module available in your program. If you use this kind of import statement to import an entire module named module.name.py, each function in the module is available in this particular way. So the syntax is module.function name. That is how you call. So the module in this particular case is pizza. So you must use the dot notation. And in a way, it's kind of good. I kind of like this style because it's kind of hard to remember all the methods in a particular module. You just type in pizza dot, and then you're going to be, from the drop-down menu, you're going to be able to select from all the members in that module, which is great for not having to remember, oh, how did I call that method, right? So let's talk about another way of doing this. What about importing specific functions? You can import a specific function into a module. So the way we do that, this is my next example here, is the syntax is the import statement is going to say from module name import function name. So from pizza import make pizza. And then we go ahead and call it, and in this case we don't use the dot notation. In fact, you can't. If you put it in, your program crashes, right? So How can you import as many functions as you want into a module? Simply just use a comma. And an example that I have here, I've only got one function, but if you were to have many functions that you would want to import, or let's say you have 10 and you only want to import 2, you would say from module name import function, one function, function 1, comma, and then function 2. So in other words, you would just simply separate each function with a comma. Okay, we can see that, here, except that we're only using one function. If I had more, I would use a comma there to import the other functions. So what is the syntax for calling a function that was imported explicitly? It's really important. That's what we're doing here. We're importing this explicitly. So with this syntax, you don't need to use the dot notation when you call a function. Because we're explicitly importing the function name, make underscore pizza, in the import statement, we can call it by name when we use the function. Okay, so all we have to do is simply, specify the name of the pizza. Of course, then you have to remember what the name is, right? In fact, I showed you here, he doesn't talk about this, but if you were to try and do pizza.makePizza, that line would crash. Again, this gives you the same output. In fact, all the little demos that we're going to be doing here, it's the same output. We're just doing a different import statement on each one of these. Let's try another example here, using as to give a function an alias. Some people love aliases. Let's take a quick look at that. So why use an alias? If the name of a function you're importing might conflict with an existing name in your program, or if the function name is long, you can use a short, unique alias, an alternate name similar to a nickname for the function. You'll give the function the special nickname when you import the function. Let's look at an example here. Here we see, we give the function make underscore pizza an alias, MP. And that's kind of neat because it's like the first character of each word there, make pizza. By importing make pizza as MP, the as keyword renames a function using the alias that you provide. So how does this alias work? The import statement shown here renames the function make underscore pizza to MP in this program. Anytime we want to call make underscore pizza, we can simply write MP open close parenthesis instead. And Python will run the code in make underscore pizza, while avoiding any confusion with any other make pizza functions you might have written in this program file. So the general syntax for an alias is from module name import the function name as fn, or whatever the function name is. So this is a great example here. I will emulate it if I ever to do this. For example, if I have a function called make underscore pizza, I'm just going to get the first character of the first letter and the first character of the second word, and put them together. It makes sense. It's very easy to read. Let's look at another example here, using as to give a module an alias. So in this particular case, did I skip that one? Let's see now. Let's see. I think I may have. Yeah. All right. So using as to give a module an alias. Okay. So how can you give a module an alias? You can also provide an alias for a module name. Given a module a short alias like P for pizza, which is what you see here, allows you to call the module's functions more quickly. So calling p.makePizza is more concise than calling pizza.makePizza. So in this particular example, let's take a quick look at it. So I say import pizza as P. Okay. I like this style too, because I can at least use the dot operator here to access the methods. So the call is much more concise. Okay. So how does this alias work? The module pizza is given the alias P in the import statement, but all of the module's functions retain their original names. Calling the functions by writing p.makePizza is not only more concise than writing pizza.makePizza, but also redirects your attention from the module name and allows you to focus on the descriptive names of its functions. These function names, which clearly tell you what each function does, are more important to the readability of your code than using the full module name. So the general syntax for this would be import module name as NM, where NM would be for whatever your module name is. In this case, the module is pizza. So I just called the alias P. All right. So let's talk about importing all functions in a module, and that's done with the wildcard, right? So we use the asterisk operator, and how does it work? So the asterisk in the import statement tells Python to copy every function from the module pizza into the program file. Because every function is imported, you can call each function by name without using the dot notation. However, it's best not to use this approach when you're working with large modules that you didn't write. So if the module has a function name that matches an existing name in your project, you can get some unexpected results. Python may see several functions or variables with the same name, and instead of importing all the functions separately, it will overwrite the functions. So what's the best approach? We have so many choices. The best approach is to import the function or functions that you want, or to import the entire module and use a dot notation. I like to use the latter. I like to go ahead and just import the entire module and use a dot notation because that helps me navigate through the library of functions. So this leads to clear code that's easy to read and understand. So it's included here so that you recognize import statements like the following when you see them, but it's not the recommended style. So using this asterisk is not the recommended way of doing things. It's just simply being covered here in the book because you very well might see it somewhere else. Okay, so let's go ahead and talk about styling functions, and then we'll talk about the do-it-yourself section of code, and then we'll talk about the summary of this particular chapter. So styling functions, how should I style functions? So functions should have descriptive names. It's really important. You don't want to just call a function by an abbreviation, or one character or something like that. These names should use lowercase letters and underscores. So don't use the other styles that you've used in other languages, whether it's like Pascal or Java and stuff like that. Your descriptive names help you and others understand what your code is trying to do. Module names should use these conventions as well. How should I style comments? Well, every function should have a comment that explains concisely what the function does. This comment should appear immediately after the function definition and use the dot string format. In a well-documented function, other programmers can use the function by reading only the description of the doc string. They should be able to trust that the code works as described. And as long as they know the name of the function, the arguments it needs, and the kind of value it returns, they should be able to use it in their programs. So how should I style default values for a parameter? Different topic now. If you specify a default value for a parameter, no spaces should be used on either side of the equal sign. So, that may have come to a surprise, be a surprise to some of you, because remember, when we're doing variables and we're doing an assignment statement, we want a space before and after that equal sign. But if we're making a default value for a parameter variable, we're not supposed to use spaces. And that's the PEP8 conventions, right? So the same convention should be used for keyword arguments. So when we have a function call, here's the function call here. Notice how there is no space before and after. That is the way, that's the convention being used in Python. And of course, it's all coming from PEP8 on here. So PEP8 recommends that you limit, your lines of code to no more than 79 characters. So every line is visible in a reasonably sized editor window. If a set of parameters causes a function definition to be longer than 79 characters, press enter after the opening parenthesis on the definition line. On the next line, press tab twice to separate the list of arguments from the body of the function, which will only be indented one level. Most editors automatically line up any additional lines of parameters to match up the indentation you have established on the first line. So here's what it should look like. So when you're creating your function definition, it's going to be really, really, really long. After the opening parenthesis, press enter and press tab twice, and then continue from then on. And if it's still real long, then you press enter again. When you press enter again, most editors will remember that you press tab twice and it will align. So then when you finish your function definition line, that first line, other languages sometimes call this the signature, right? Your body, or the body of the function, should only be indented one time, not two times. So how to style your program or module with more than one function? This is something I've been having a little bit of trouble getting used to, guys. I don't know about you, but PEP8 likes 2 blank lines, right, between my functions. So if your program or module has more than one function, you can separate each by 2 blank lines to make it easier to see where one function ends and the next one begins. But it just, it's getting hard. That's a hard one for me to follow, because it just looks like too much white space. But yeah, that's the way PEP8 likes it. So where should import statements be written? In this next question, all import statements should be written at the beginning of a file, at the very, very top. The only exception is if you use comments at the beginning of your file to describe the overall program. Okay, so let's go ahead and talk about the try it yourselves on here. And the try it yourselves, I'm going to go ahead and put those in Visual Studio so I can go ahead and just do something different. So this is 8.15, and in 8.15, it's called printing modules. And it says put the functions for the example printing underscore modules.py in a separate file called printing underscore functions. Okay. Write an import statement at the top of printing modules and modify the file to use the imported function. So this is what we end up with. So here's the file that contains only the functions. All right. See, there's no calls in here, right? We've got 2. And I'll come back to it, but let's go ahead and look at the main program here. In this one here, at the very top, we import the first file, and we're going to go ahead and give it an alias of PF, printing functions. So this entire module is now can be referenced as PF. So what happens here is on line 3 and 4, I create line 3, I create a list, and then on line 4, create an empty list. And what we're going to do is we're going to then call print modules, and we're going to pass it the unprinted designs as well as the completed modules. Let's go ahead and take a quick look at that. So that's print modules here. We'll receive both of those lists, and it uses a loop. Remember how we used to do this? And what it does is in this loop, we get the first unprinted design, we pop it and put it into the current design. And then we simply say printing, and we're printing that current design. And then we go ahead and append that to the completed modules. So it's, as we're popping it out of one list, we're putting it into the other list, right? And then the next function that's called is called show _ completed modules. So that would go ahead, and the flow of control would then come over here, and we would loop through completed modules. We would say for completed module in completed modules, and we would print out each one. Okay. So if I do a Control B, now why do I want to do a Control B on this? This is Visual Studio Code. We're going to run that here at the bottom. Something went wrong. Okay, let's see here. Let's see. Let me close that. It may have been from the past on here. So here's the module that does not have any calls to it. Let me go ahead and run that. And as you notice, nothing happens, right? Because there's no call, right, in that particular file, right? So we close that, and let's come over here to the main one. And let me go ahead and run that again. And there's my output. So my output shows the printing module, and as it's printing, it's being popped and put into the other one. And then the other method is called, and it iterates through the completed modules. This is a great example here of something that you could use a little debugging here to understand the flow of control. I'm going to go to line 3 and put a breakpoint, and then I'm going to go ahead and go to run, start debugging Python file. And instead of pressing on the icon here, I'm going to go ahead and press F11. So notice the line that's highlighted, line 3, is the line that's going to get executed but hasn't gotten executed yet. So when I press F11, it goes and goes to the next line of code, and then it comes over here into the other file. So now we're inside of the we're inside of the other file, and we're going to be looping through that. And you can see the outputs being outputted here, printing module, robot, and it's going to and appending. And so now flow of control comes back to the first file on here, and we are then going to go on to the next function and call that. So then flow of control comes to the module that contains the two functions, and it's going to iterate through the completed mobs. And that is the end of that little demonstration on the try it yourself. Now, the other try it yourselves were involved using programs that you've written before and going through and for example, using all the different import statements, such as import the module name. You could go ahead and import a specific function. You can import a specific function as an alias. You can import the entire module as an alias, or you could use the wildcard. Remember, we said the wildcard was not something that was recommended. The next one was 8.17. was simply to review your programs and see if they conform to the styling guidelines. So finally, that brings us to the summary of this chapter. And this chapter was, like I say, I'll say it's probably one of the best written chapters on functions that I've read. It covered quite a lot. So what did you learn in this chapter? So in this chapter, you learn how to write functions and to pass arguments so that your functions have access to the information they need to do their work. I've seen a lot of introductory books, and that's about as far as they go. Look at all the other stuff Eric threw in to this chapter. The next thing that we learned was how to use positional and keyword arguments and how to accept an arbitrary number of arguments. We saw functions that display output and functions that return values. In other words, a return statement, right? We learned how to use functions with lists, dictionaries, if statements, and while loops. So we were able to, create functions that did more than just say something like, I'm in the function now, which is many times what you'll see in an introductory class. You also saw how to store your functions in separate files called modules. That's what we covered in this video. So your program files will be simpler and easier to understand. Finally, you learned to style your functions so that your programs will continue to be well structured and as easy as possible for you and other to read. So, I'm a proponent of making simple code. I think a lot of times when programmers say they're going to make something simpler, they actually make it more complicated. But so simple code is easy to maintain. So one of your goals as a programmer should be to write simple code that does what you want it to do, and functions help you do this. They allow you to write blocks of code and leave them alone once you know they work. When you know a function does its job correctly, you can trust that it will continue to work and move on to your next coding task. So functions allow you to write code once and then reuse. That's a really important word here. Reuse that code as many times as you want. When you need to run the code in a function, all you need to do is write a one-line call and the function does its job. When you need to modify a function's behavior, you only have to modify one block of code and you change takes effect everywhere that you've made a call to that function. So using functions makes your program easier to read, and good function names summarize what each part of the program does. Reading a series of function calls gives you a much quicker sense of what the program does than reading a long series of code blocks. So functions make your code easier to test and debug. When the bulk of your program's work is done by a set of functions, each of which has a specific job. That's a really important thing that he wanted to bring, philosophy that he had. Each function should do one thing. If it's trying to do more than one thing, then you really should cut it up into another function. So each of which has a separate job. It's much easier to test and to maintain the code that you've written if you've done it this way. You could write a separate program that calls each function and test whether each function works in all the situations that it encounters. When you do this, you could be confident that your functions will work properly each time you call them. We'll be working on this particular topic in chapter, what is it? I think it's chapter 11. So what are you going to learn in the next chapter? Now that we've learned all about functions, in the next chapter, we're going to learn about classes. Yeah, the beginning of object-oriented programming. So classes combine functions and data. Those are the two important terms that we're going to be learning about. And we combine them into a neat package that can be used in flexible and efficient ways. So that, my friends, is the end of this chapter on functions. I hope that you picked up a thing or two, and I will see you in the next video.